Okay, this time I have a 1541 disk drive, very similar to the disk drive in the previous video, except this time this has a totally remanufactured magnetic coil in the reed head. The old reed head had been broken and it's been expertly repaired, and we will test this out on this oscilloscope. Now I'm using the same setup procedure as in the last setup. So the cursor 1 is set to 6.96 volts, which is this cursor here, the little dotty thing, and cursor 2 is 5.24 volts, which is this cursor here. One thing to note is that the baseline voltage is slightly lower than the other disk drive. The other disk drive, its base voltage was slightly up from here, and you can check in the video to confirm that. The time base is still 5 microseconds, and the greater kill scale is set to 1 volt per division, so that's a 1, 2, 3, 4. And this couple of interesting things to note is here, where there's supposed to be a capacitor, it's just a wire link, just here. As you can see, there's a wire link just there, and there's another wire link just here. Apologies, that was the one I was pointing to before. So there's that one there, and then there's this one here, which is a resistor. Now this resistor, I believe, refers to this resistor here. So I don't know if that has anything to do with the performance, but it is very close to the second stage amplifier UF4, which is this one here. So I'm not sure there. I'm using the same setup, the alignment disk program through Vice, and I'll start the program off and we can see how it runs. Now you'll notice that the waveform is very, very similar to the previous video. However, one thing to note, and it's very pronounced, is that the actual amplitude is a lot lower, maybe 3 to 4 times, even more maybe. Interesting to note though that the disk drive is actually reading. So the disk drive will actually pick up the data on the disk even at these reduced amplitudes. So it's probably, I would say it's probably tolerant. However, you'll notice that the read signals are slightly down a bit, and I'm using the same factory demo disc that I used in the previous video. Now, what I think might be happening is if somehow this circuit here could be just tweaked a little bit to amplify the signal just fractionally, maybe not even 200 millivolts, maybe 200 millivolts to say 500 millivolts, may get better performance in reading and writing original discs. So that's just something to be maybe for future thought, to think about. I'm not sure there, but it's very interesting. Okay, I've just worked out that C48 here, which is a link, but it has a symbol for a capacitor, is part of UF3, which is the primary amplifier, is C48, and there's a capacitor there. So I think that says 1.1 microfarads, and the other linked one is, can't make that out, maybe I can check it on another data sheet to see what that capacitance should be. Or actually, no, I take that back. That is actually a resistor. So R23 looks like maybe 330 ohms, maybe? I'm not sure. I'll check that. Now I've got the probe now hooked up to the junction of C42 and R23, which is this one, so the other side of the amplifier here, and we'll see what the signal is doing. And you can see the signal is very similar to when it's hooked to the other side of the operational amplifier. So there's not much difference. Now, unfortunately, the signal is very small and I can't determine if the signal gets bigger or smaller depending on where the read head is on the disk drive. But I would suspect that the read-write head amplification will get bigger and smaller depending on where the disk reading on